Hello friends, in today's video we derive the equation of motion for single degree of freedom undamped free vibration system by using the conservation of energy principle. So what the conservation of energy principle says, the kinetic energy plus potential energy is equal to constant. Total amount of energy is fixed, it doesn't change. It can be transformed one form to another form. This equation can be rewrite as the derivative kinetic energy plus potential energy equal to 0. Let's say this is the equation 1. So here we have a system at the equilibrium position, static equilibrium position, and mass m and the spring is k, spring constant k. So in this spring mass system, the kinetic energy is stored in a mass by virtue of its velocity, and it can be write down as kinetic energy of mass is equal to 1 by 2 mx dot square, mass and the velocity of mass. Differentiate this kinetic energy, we get mx double dot, same as the potential energy stored in a spring by virtue of its elastic deformation, and the potential energy can write down as 1/2 spring constant into deflection square. And when we differentiate this potential energy, we get kx. And let's put those value of differentiate of kinetic energy and potential energy into equation 1. We get mx double dot plus kx equal to 0. This equation number 2 is our equation of motion of single degree of freedom undamped free vibration system. And this differential equation, when we solve this differential equation, we get the response as t a1 cos omega nt plus a2 sin omega nt. Here the omega n is equal to square root of k by m. If we have let's say at time t equal to 0, we have an initial displacement x0 and the initial velocity x dot 0, and when we x t is a displacement value, displacement of the system, and x of t is the velocity of system. Then we have the value of t equal to 0. We have a1 equal to initial velocity, initial displacement, and x dot at t equal to 0. We have omega n a2 equal to x dot 0. Now we have a value of a1 and a2. a2 is equal to x dot 0 divided by omega n. Now we have a value of a1 and a2. We can write down our response as x of t equal to x0 omega nt plus x dot 0 divided by omega n sine omega nt. Let's say a1 is equal to a cos phi and a2 is equal to a sin phi. Then we can find this new constant a and phi by the from the value of a1 and a2 we find out before. A is equal to a1 plus a2, like a1 square plus a2 square raised to 1 of half is equal to x0 square plus x dot 0 square divided by omega n square or raised to 1 half. And the value of phi can be found out as tan inverse a2 divided by a1, which is equal to x dot 0 divided by x0 omega n. Now the response can be write down as x of t is equal to a cos omega nt plus phi, and the value of a is we can find out using this equation, and the value of phi can be find out using this equation. So this one is like tan inverse of this. Omega nt, here this one tan inverse x dot 0 divided by x0 omega n. So this way we can find out the equation of motion using the energy method. And that's all guys today, and thank you for watching this video.